alaikum wa rahmatullah. Today experiment we have new gas diffusion experiment. So the aim of this experiment to determine the diffusivity DAP from diffusivity from A to P for a certain substance or a certain molecule. Okay. Now, as you know, the flux of A NA equal minus DAB differential of CA over DZ plus CA times V, and V is the average molar velocity, and it's equal to flux of A plus flux of B over total concentration if you have both component A and component B in your system. So now, if suppose that you have your system is stagnant, that means NA has flux into B, but there is no flux of B. So NB equals 0. So NB equals 0. Then the equation will be in the flux of A minus DAB times DCA over DC plus CA times NA over CT only. Let's take this part, okay, and move it here. So NA minus CA NA over CT equal minus DAP times DCA over DZ. Now let's take NA as a common factor. So NA 1 minus CA 1 over CT will be equal to minus DAP DCA over DZ. Okay, so again I can move this part here. Okay, so NA, the flux of A, will be minus DAB DCA over DZ 1 over 1 minus CA 1 over CT. So now if I multiply this part of equation to CT over CT, so it's equal 1. So now it will be CT over CT minus CA, because CT this will be cancelled and this will be CT, so CT minus CA. So now I can integrate this equation, but before integration let's do some arrangement. So NA times DZ, so DZ I put it here, times DZ equal minus DAP CT DCA, I move it here, over CT minus CA. So just what I did here, I just moved CA to this part and CT to this part, and DZ I moved here to make integration. So now let's integrate from Z1 to Z2 and from CA1 to CA2. So now NA times Z2 minus Z1 equal minus diffusivity of A to B times CT minus ln CT minus CA2 over CT minus CA1. Okay, now we have a minus here and minus here, so we have a positive. So NA Z2 minus Z1 equal the diffusivity of A to B CT ln CT minus CA2 CT minus CA1. So I can this diffusivity if CA2 and CA1 are known. But now we have flux from A to B, so the concentration of the bulk changed. So I have also changed in the CB, because we have CA and CB. So and put together form C total. So it's we must introduce the mean bulk of change. So that means we want to introduce CLM. Okay, CLM is the average logarithmic average of the B component. Okay, now in order to introduce this, we multiplied this part of equation by this one. Okay, this one equal 1. Okay, it's equal 1 because the same component here, same definition here, items here, equal to same here. So if I divide two equals, it will be equal 1. Okay, so now CT minus CA2 minus again CT minus CA1 divided by CT minus CA2 minus CT minus CA1. So I just introduced this part in order to make a balance for equation and introduce CBM. Okay, so now the equation, so just I multiplied this one to here. Okay, now CT minus CA2, this is minus and this is minus, CT will go with CT. So this is minus and this become positive. So this part will be CA1 minus CA2. Okay, as we said here, CB, C total equal CA plus CB. Okay, so CT minus CA2 equal to CB2 and CT minus CA1 equal CB1. Here also CT minus CA2 it will be CB2 and CT minus CA1 will be CB1. So now let's write the equation again. So we can get NA Z2 minus Z1 equal DAB times CT ln CB2 minus CB1 times CA1 minus CA2 over CB2 minus CB1. Okay. So this part I can move it below here. Okay. So NA Z2 minus Z1, the diffusivity of A to B times CT will be equal to CA1 minus CA2 over CB2 minus CB1 over again ln CB2 minus over CB1. So this part from definition is CBLM. So it's the logarithmic mean of bulk B. Okay. So let's write it. NA times Z2 minus Z1 equal DAPCT times CA1 minus CA2 over CPLM, where CPLM equal to CB2 minus CB1 over ln CB2 over CB1. Okay. As you know, NA is the mole flux, molar flux. So it's equal to moles divided by area times T. So it's mole rate divided by area. And moles, you know, it's equal mass over molar mass times area times T. And mass is density times volume. So over molar mass times area times T. So we can write in terms of differential form, NA equal density is rho equal molar mass MWT times volume over area, so it will be L or Z. Okay, so it will be dZ over dt because we wrote it in differential form. Now let's replace the NA by this in this equation. So rho over molar mass times dZ over dt equal dZ2 minus dZ. This part. And this all equal to diffusivity of A to B, total concentration, CA1 minus CA2 over CPLM. So now we can rearrange the equation in order to do another integration. So dZ, okay, dZ2 minus dZ1, we just moved this one and we move the T to the other part. So it will be DAP CT times molecular weight over density CPLM CA1 minus CA2 times delta T. By integration from Z1 to Z2, okay, and time from 0 to time, okay, I will get Z2 squared minus Z1 squared over 2. Okay, this is the integration of this part equal diffusivity of A to B CT molecular weight over rho CPLM times CA1 minus CA2 times T. So from this equation, I can find diffusivity. So diffusivity equal the Z2 squared minus Z1 squared over 2 times rho CPLM CT microwave CA1 CA2. So now we can utilize this equation to apply it experimentally to find the diffusivity. How come? Okay, now we have this tube. This tube, we want to suppose that we have acetone, but you can use any other compound, any other component or organic liquid you want to test its diffusivity, acetone. So now this acetone, we want to measure the diffusivity of acetone per certain time. So we need, in this equation, we need concentration of Ca and concentration at point A. Suppose this is the first point, this is point 1, and this is point 2. So Z1 and Z2. We need also to find the concentration of Ca1 and Ca2. As you know, PV equal nRT. Then C is a molar concentration equal number of moles per volume, and it's equal to P over RT. So if I know the partial pressure of any component, okay, at certain a specific place, so I can find its concentration because R and T are already, you can find them. So partial pressure. But I want to find the partial pressure here at this point. So now, if I use pure solvent, okay, so you can find P from Dalton rho, you can find from Raoult's rho, you can find P A equal X1 times P star. And since it's pure, so X will be equal 1. So PA will be P star. How to find the P star? From Antoine equation, you can find from Antoine equation, you can find P star. So by this, we could find Ca1. Now, for Ca2, how to find Ca2? Actually, we already have pure solution, so we can find it. But here we don't have anything to find. So the better way is to just get rid of this gas. So I'm just putting a pump, okay, air blower, so it's remove any accumulated CO2. So always Ca2 become 0. Okay, so now this equation will be Ca1 minus 0. I don't have Ca2. Okay, and C total equal Ca plus Cb. Okay, C total will be Ca plus Cb. Now, the other part, I can determine the amount Z2 minus Z1. This is the difference in the length, Z2 minus Z1. Okay, but actually from the equation, Z squared 2 minus Z squared 1, and Z squared 2 minus Z squared 1 equal to Z1 minus Z2, as you know, times Z2 plus Z1. But so I have a problem here because the equipment only measures the difference in height. So I can make it, okay, Z2 minus Z1 plus 2Z1. So plus 2Z1, so it will be plus Z1. So I will use this equation. This is like a mathematical trick. So now let's apply, put this one here. So it will be Z2 minus Z1 times Z2 minus Z1 plus Z2Z1 times rho CPM 2 CT molecular mass Ca. Of course, we remove the Ca2, it's not there, times T. Okay, in order to experimentally determine the diffusivity at different time, so now we can rearrange the equation. We can take T from here and Z2 minus Z1, just move it to the other part and move diffusivity to this part. So T over Z2 minus Z1 will equal to this part, Z2 minus Z1 plus 2Z1 times rho CPM over 2 CT times molar mass times CA1. So now again, then we can this part times this part and this part again times this part. So if I plot T over Z2 minus Z1 on the y-axis and Z2 minus Z1 on the x-axis, I can have this as slope. And all this part as intercept. Okay? So I don't care about it. Okay? So if you from the raw data, if you has T and Z2 minus Z1 from the as time going experimentally, you have stopwatch, you can measure the amount of Z2 minus Z1 as the time go, so the surface will go down and the distance increase. So then you can take for time, any time you want, from time 0, after 30 minutes, after 1 hour, whatever the time you want, and determine each Z2 minus Z1. So you will get this line, point like this, the slope, okay? It can tells you the DAP, because you already know how to calculate CA1 is equal to P over RT, okay? From and P we got from Antoine equation, and for CT is total pressure, atmospheric pressure, because we are working in atmospheric pressure over RT, okay? Then again for CBM. Now CBM, we want two CB, we want two CB. We want CB1 and we want CB2 in order to find CBM. Okay, CB1 equal C total minus CA1, and CB2 equal C total minus CA2. So since you already determined the amount of CA1 and you already know the C total, so you can CB1. For CB2, of course, CA2 is equal 0 because I don't have CA2, I already removed it. So CB2 will equal to C total, then you can find the CBM and you can accordingly find the diffusivity. So this is all about the experimental way to find the diffusivity from the equipment. Now we will go for the equipment to show how you can read the levels, and we will explain the setup of the equipment as well. Thank you. So this T-tube, we already have a syringe to put the acetone in the tube, and we have a level, and it has inlet and outlet in order to put air to draw any accumulated air in the top of the T-tube. Now we have our experimental setup. We already set the temperature at 45. You can set the temperature at any other point if you want. If you want to measure the temperature higher or lower, you can set. We put our T-tube here, okay, and we also put a thermometer to make sure the result reading here is exactly here, because temperature is a very important factor. And this one is bath water to ensure the temperature is exactly and it's diffused through the equilibrium, through the tube. Again, so now the important thing also is to open the air pump. So I have to connect the tube to the air pump. Okay, and this used, as we said, to remove any accumulated concentration of acetone at the top of the column of the tube. Now, from the sliding microscope, we just adjust the scale at 0. Okay, I can see here the surface, concave surface of the acetone. So it's at 0. Okay, now it's exactly at 0. And then by stopwatch, just record the surface and record the time, and wait until certain time then again check the level again, okay, and record the new height with the new time. And that's it until get at least 5-6 readings, تمام? And at least take 5-6 raw data, so it will be your final results. So, and then if you want to repeat the experiment again at different temperature, you can do it. So this is all about experiment today. That's it. Thank you so much.